Operating structure of the B-2 Spirit aircraft. The B-2 Spirit, also known as the stealth bomber, is a strategic heavy bomber developed by Northrop Grumman for the United States Air Force. Designed to penetrate dense air defense systems and carry both conventional and nuclear weapons, the B-2 features an advanced operating structure focused on stealth capability, survivability, range, and payload capacity. Its design reflects the integration of aerodynamic systems, structure, avionics, engines, and coordinated control operation to provide superior capability on the modern battlefield. Aircraft frame design and structure. The operational structure of the B-2 Spirit is fundamentally shaped by the flying wing configuration, eliminating the traditional fuselage and tail structure. This design minimizes the aircraft's radar cross-section, RCS, making it highly stealthy. Composite materials. The aircraft frame is primarily made from carbon graphite composite materials, which help reduce radar reflection and overall weight. These composite materials are coated with radar-absorbing material, RAM, to reflect or absorb incoming radar waves. Interceptor weapons bay. To maintain stealth capability, and all weapons are carried inside the aircraft's body. The B-2 has two large internal weapons bays that can hold various types of munitions, including B-61 and B-83 nuclear bombs, Joint Direct Attack Munitions, JDAM, and Massive Ordnance Penetrator, MOP. Control surfaces. The B-2 uses split rudders, elevons, and winglets for flight control. These components work together to provide roll, pitch, and yaw control in the absence of a vertical stabilizer. 2. Propulsion system. The B-2 Spirit is equipped with 4 General Electric F1 GE 100 turbofan engines, each providing 17,300 pounds of thrust. Engine integration. To maintain stealth capability, the engines are embedded within the wing structure. The air intakes are shaped with curves to shield the engine fans from radar detection. Exhaust and infrared reduction system. The exhaust system is flattened and cooled by mixing with surrounding air to reduce the aircraft's infrared signature. Hot gases are dispersed over a wide area through special slot-shaped nozzles, making the B-2 difficult to track with infrared sensors or heat-seeking missiles. 3. Stealth technology. Stealth is a core operational attribute of the B-2 Spirit, achieved through a multifaceted structural strategy. Low observability, LO. Design. Every aspect of the B-2's shape is optimized to deflect radar waves. Smooth and rounded edges, no protrusions, and the use of radar-absorbing coatings all contribute to reducing the radar cross-section. ARSA, radar-absorbent materials, RAM. Special paints and coatings are applied to the aircraft's exterior surfaces to absorb radar energy rather than reflect it. The B-2 also uses radar transparent leading edges. Electronic countermeasures. The aircraft is equipped with an integrated defensive management system, DMS, capable of detecting and identifying and locating enemy radar sources, helping the pilot avoid or jam signals. 4. Flight control system. The B-2 does not have traditional aerodynamic stability and must rely on a fly-by-wire FBW flight control system, continuously adjusting control surfaces to maintain balance and maneuverability. 4-layer redundant FBW system. This computer-based system decodes pilot commands, and translates them into precise movements of the control surfaces. The instability of the B-2 is continuously corrected by computer adjustments. Autopilot capability. The advanced autopilot system supports long missions by automatically adjusting altitude, heading and course with very high accuracy. Manual and emergency override mode. Pilots can override the automatic systems when necessary, and backup subsystems ensure control is maintained in case the main system fails. 5. Avionics and mission system. The B-2 Spirit uses an advanced integrated avionics and mission control system for navigation, communication, threat detection, and targeting. Navigation. Combines inertial navigation system, INS, GPS, and star navigation to ensure highly accurate positioning, even in GPS-denied or jammed environments. Communication, UHF, secure VHF communication systems, satellite communication, SATCOM, and data links support real-time coordination with command centers and other assets. Radar and sensors. The B-2 is equipped with the ANAPQ-181 radar using low probability of intercept, LPII waves to avoid detection. Terrain-following radar allows low-altitude flight in adverse weather conditions. Threat detection and management. The Defensive Management System, understood DMS, monitors the electronic environment, identifies radar threats, and suggests evasive maneuvers or jamming responses. 6. Mission planning and software integration. Before any mission, the B-2 undergoes a thorough mission planning phase, including route planning. Pilots and mission planners use specialized software to chart flight paths that minimize exposure to radar and air defense systems. The DMS system supports dynamic replanning throughout the mission. Weapon configuration. Based on the mission objectives, the weapons bay is equipped with an appropriate mix of precision-guided munitions or nuclear weapons. The onboard systems are configured accordingly, system updates and software loading. Mission data, including waypoints, threat data, and target coordinates, are uploaded to the aircraft's central electronic system. 7. Crew operation and human-machine interface. The B-2 is operated by a two-member crew, a pilot and a mission commander. The cockpit is designed to ensure comfort and functionality during extended missions. Cockpit layout. The cockpit includes multifunction displays, MFD, a heads-up display HUD, and data input systems for flight control, navigation, and weapons management. Ergonomics. The cockpit features reclining seats, an oxygen system, and even a small space for resting, as missions can last up to 40 hours. Redundancy and safety. Critical systems are supported by backup electronic and mechanical devices to ensure continuous operation. 8. Maintenance and support infrastructure. The B-2 operational structure extends to ground support systems. Low observability. Maintenance. The stealth coating requires specialized care. The maintenance team uses mobile clean rooms and climate-controlled environments to apply the RAM coating. Diagnostics and prognostics. Advanced software systems monitor the aircraft's condition and performance. The Integrated Vehicle Health Management System, IVHMS, predicts component failures and schedules maintenance in advance. Hangar facilities, dedicated hangars called Dock 61 and Dock 62 at Whiteman Air Force Base, are climate controlled to protect the sensitive coating and stealth systems. 9. Operational capability and deployment. The structure of the B-2 Spirit allows it to carry out missions worldwide, often originating from its main base in Missouri. Global range. With aerial refueling capability, the B-2 can fly intercontinental missions without landing. It has a combat radius of 6,000 nautical miles without refueling and an almost unlimited range with tanker aircraft. Diverse payload, it can carry up to 40,000 pounds of weapons, including 16 nuclear gravity bombs, B-61 or B-83, 80 pounds 500-pound JDAMs, 16 2,000-pound GBU-31 JDAMs, large bunker buster bombs used for underground destruction missions. Precision strike. The aircraft can attack up to 80 targets in one mission with a precision guidance system ensuring minimal collateral damage. 10. Strategic importance and future improvements. The unique operational structure of the B-2 makes it the foundation of the United States' strategic deterrence capability. Survivability. The combination of stealth capability, speed, high-altitude flight, and electronic warfare systems gives the B-2 high survivability in contested environments. Force enhancement. As a stealth bomber, it can neutralize high-value targets early in a conflict, allowing other forces to operate more safely. Upgrades. The B-2 fleet has undergone continuous modernization, including upgrades to communications, EHF SATCOM, DMS hardware, weapon integration, software systems and cockpit interface. Transition to B-21 Raider. While the B-2 remains in service, it will gradually be supplemented and partially replaced by the B-21 Raider, which is developed based on the B-2's operational structure with modern technologies. Conclusion. The operational structure of the B-2 Spirit represents the pinnacle of aerospace engineering, combining stealth design, powerful engines, advanced avionics systems, and strategic capabilities. Each system, from the internal weapons bay to the fly-by-wire controls, serves a specific function aimed at enhancing survivability and mission effectiveness. As both a symbol and a tool of modern air power, the B-2 Spirit continues to evolve, maintaining its role as a critical asset in the United States Air Force's global strike capability.